All right, now let's solve this rational inequality. Remember, as soon as you see it's an inequality, you know you're going to wind up plotting some critical values on a number line and doing test values and all that. So that's where we're headed. So the first thing you need to figure out is what are those critical values that you're going to plot on this number line. What are they? Well, for these types of problems, they're going to come from two sources. We're going to get critical values by setting this up as an equation. And solving. So when I solve this, that'll give me some points on my number line. But also, right now, I will have other points on the number line will come from excluded values. So looking at the x plus 2, that tells me that x cannot equal -2. So that's a critical value. That's going on the number line. All right, so now let's go ahead and solve this equation and see what else goes on the number line. Well, to solve this equation, we need like denominators. Okay, I see x plus 2 is my only denominator. So I'm just going to put x plus 2, and I'll put x plus 2. And we'll have to put it in the numerator as well. All right, now this over here is silly because I know this is going to just be 0. All right, 0 times anything is 0. But anyway, now my denominators are the same. Once I have the like denominators, I can cancel these denominators out. So I'm going to have x plus 12. Now, when you distribute this, you're distributing -3, not +3. So this will be -3x minus 6. All right, is equal to 0. Like terms, so x and -3, that's -2x. 12 and -6, that's +6, is equal to 0. I'm just going to get x by itself, so subtract 6 from both sides, so that leaves me with, no, I better not. So that's going to leave me with -2x equals -6. Divide both sides by -1. Divide both sides by -2. I'm not just changing the signs. I'm trying to get x by itself. So that'll give me x equals +3. So this is going on the number line. So let me get ready. So let me just write these side by side. So these are my critical values. All right, my excluded values and my solutions. So let's go ahead and set up the number line. Okay, so I have -2 and I have +3. Now, excluded values are always graphed as open circles. All right, they're excluded, and an open circle means excluded. Now, the solutions are sometimes graphed as open circles and sometimes closed circles, depending on whether or not you have this or equal to. And this time we do. So we want to include any points that cause the function to equal 0. And that's what this is. We set it equal to 0 and solve. So a value of 3 will cause the function to equal 0, and we want to include that. So we'll use a closed circle. All right, now is when we do test values. Over here to the left of -2, we have -3, for example, or you could use -4 or -5. In between -2 and +3, you could use -1 or 0 or 1 or 2. I'm just going to use 0. Over here to the right of 3, I'm going to use 4, or you could use 5 or 6 or whatever. So these would be good test values. Now I'm going to use my calculator to help me evaluate this. Okay, so let's just clear that out. And we're doing x plus 12 over x plus 2. So we have x plus 12 over x plus 2, and then minus 3. All right, make sure you're in Ask X mode. So I want to evaluate the function at -3, 0, and 4. Okay, so -3, 0, and 4. So that's -12, 3, and -1/3. All right, so that's -12, 3, and -1/3. In each case, I'm trying to figure out if the function is greater than or equal to 0. So is this greater than or equal to 0? How about this? How about this? Okay, is this greater than 0? No. That's negative. Is this greater than 0? Yes, it is positive. Is this greater than 0? No, it is negative. All right, so the yes tells me where the solutions are. So apparently the solutions are here between -2 and 3. So in interval notation, I would write -2 to 3. All right, open circle, bracket. All right, I'm sorry, parentheses, bracket, because open circle, close circle. So this would be the solution in interval notation. Okay, this video is not very long, so I think we will just go ahead and do number 4 as well. Okay, so one more time, let's solve this inequality. And so again, we're going to wind up dealing with a number line and some critical values. So remember, we have 2 sources of our critical values that go on the number line. One source is excluded values. So let's write that down. X cannot equal 0 because of this denominator of x. All right, the other values that will go on the number line will be solutions to the equation that you get if you replace this less than or equal to sign with just an equal to sign. Okay, so let's solve this equation. We need the denominators to be the same, so I'll go xx. Then, now that the denominators are the same, I can cancel those out. So that's going to give me x squared minus 3x minus 10 is equal to 0. Hopefully this will factor. Otherwise I have to do the quadratic formula. So I have x times x, 10. It's probably going to be 2 times 5, positive 2, negative 5. Okay, because inner plus outer equals middle. Inner I have 2x, outer I have negative 5x. That's how you get negative 3. So I can get the solutions to this equation by setting these equal to 0. So here I will have x equals negative 2, x equals positive 5. So let me add that to my list. So x equals negative 2, x equals positive 5. So these are the 3 values. The solutions and the excluded value all go on the number line. Okay, let me leave myself plenty of space. So here comes the number line. All right, so it's going to be like this. So I'm going to put them in order, of course. So I have negative 2, and then the middle here should be 0, and then over here it should be 5. Okay, so remember, excluded values are always open circles. So my excluded value is this 0, so that's going to be an open circle for sure. Now, I'm not sure why I'm making it so big. All right, now the solutions will sometimes be open circles and sometimes be closed circles. all right? We're going to include these solutions because we want the values that cause the function to be equal to 0, all right? Because that's what this means, less than or equal to 0. All right, these are the values where the function is equal to 0, because look, that's what we did. We set it equal to 0 and solved. So these will be closed circles to show that these will be included in the solution set. Okay, so now it's time to do our test values. We'll need 1 over here to the left. I'm going to do f of -3. I need 1 between -2 and 0, so I'll do f at -1. I need 1 between 0 and 5, so I'm going to do f of 3. Here, I could have done 1, 2, 3, or 4. And I need 1 to the right of 5, so I'm going to do f of 6. Okay, so to test these out, I'm going to put this in my calculator. Let's see, x squared minus 3x minus 10. Over x. All right, be in ask x mode. All right, and the values I want to evaluate are -3, -1, +3. Okay. I feel like using a different color.
Hello.
Hello. And then there's 6.
Huh?
Oh, I'm just talking to the video. So that'll be 4 over 3. And in each case, we're asking ourselves, is the function less than or equal to 0? So is this less than or equal to 0? 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 Yes, this is less than 0 because it's negative. No, this is positive, so it's not less than 0. This is less than 0 because it's negative. This is not less than 0 because it is positive. So we have a yes, no, yes, no. The yeses show us where the solutions are. So we'll indicate these solutions by drawing an arrow here and a segment from here to here. So this is a graph of my solution set. So in interval notation, all right, for this first portion, that's from -infinity to -2. So I will put -infinity to -2, round and square bracket. Then union 0 to 5, round and square. So this would be the solution set in interval notation.